Now, in example D, they're giving us a derivative function where you have the binomial 2x to the fourth minus x, all being divided by x cubed. They're also telling us that f of 1 equals 10. Notice that is in the original function. So we know we have a point 110 that is in little f of x. In other words, the antiderivative. So let's find the antiderivative. Notice it is really difficult to go backwards with a rational the way it's written. So I would recommend rewriting the derivative function first by splitting it up if you can. Since the denominator is a single monomial, we can write it as 2x to the fourth over x cubed minus x over x cubed. So again, it's still the derivative. When we simplify it, we get 2x minus x to the negative 2, 1 over x squared. So again, that is the derivative. So now we're going to find the antiderivative. It is important to use the right notation. Notice I kept it as f prime, so I know where it is when I start taking the derivative. So for this first function, we're going to add 1 to the exponent, divide by 2. For the second term, we're going to add 1 and divide by that negative 1, which would give us a positive 1 there, and then we're going to have a plus c. So this nice antiderivative function is x squared plus 1 over x plus c. But notice this doesn't give us the whole function. We still have that plus c here. How can we find what that constant actually is? Guess what? That's why they gave us this. If it's an arbitrary function, you're going to have an arbitrary c. But if they want the actual specific function, they have to give you a point. So let's plug it in. We know that if x equals 1, then f of 1 equals 10. So we would get 10 equals 1 squared plus 1 over 1 plus c. So 10 equals 2 plus c, so c equals 8. Now we have our final function. F of x equals x squared plus 1 over x plus 8. If they give you a point, the c is no longer arbitrary. So now let's take a look at example E, the daily marginal revenue function. Remember, marginal revenue function, we can call that M of R, as we learned before, is the same thing as the derivative of the revenue function. So the marginal revenue function for a lamp company is given by MR of x equals 30 minus 0.0003 x squared. That's the same thing as saying this is R prime. X represents the number of lamps sold, which will be between 0 and 500 included. Given that the revenue is $1,487.50 when the production level is 50 lamps, determine the revenue at 200 lamps. So what are they asking us to find? Revenue, not the derivative of the revenue, but the revenue. And a hint is also it's 200 lamps. We can say that the marginal revenue of x, which is the same thing as the derivative of the revenue function, is 30 minus 0.0003 x squared. So we need to find the integral of that marginal revenue function, which will give us the revenue function. So that would be 30x minus, we're going to take that x and add 1 to it, so we get 3. And when we divide by 3, we get 0.003. 0.001. And that plus C. Oftentimes I remember the plus C once I start plugging in the numbers and realize I have nothing else left. So we have to have that plus C. So now we're going to use the point that was given. And that was the fact that when the production level is 50 lamps, the revenue is 1487.50. So let's plug those in. So in this case, the C equals 0. And yeah, okay, I agree with you guys. We did all that work and there is no constant. So that's a lame example. But with that lame example, we know that this then is our revenue function because C equals 0. And we want to know what the revenue is at 200 lamps. So let's find it. Revenue at 200 would be 30 times 200 minus 0.0001 times 200 cubed. So we've determined that the revenue at a production level of 200 lamps is $5,200.